Hello and welcome to the next video dealing with straight lines, and in particular we're going to look at gradients. You're going to see this concept of straight lines throughout the A-level course, and the building blocks of straight lines are very important for any questions regarding tangents, normals, especially when it comes to later topics in differentiation. So, first page dealing with straight lines in your workbook deals with the subtopic of gradients. A gradient effectively measures the steepness of a line. Okay, the ratio between how far along you go across the x and how high you go up across the y. And the formula for a gradient is given as such. And the symbol for gradient is m. Very important that we understand these symbols. Okay, so the gradient of a line joining two coordinates x1, y1, x2, y2 is given as such: y2 minus y1 over x2 minus x1. It is very important that you get the order of this correct. Okay, so essentially we're looking at a change in y over a change in x. Okay, and if you happen to incorrectly do y2 minus y1 over x1 minus x2, you'll get the wrong gradient. And I've seen it commonly, in year 12, some students get this the wrong way around completely, so they flip it instead, which obviously gives you the wrong answer. Getting the wrong gradient can have huge consequences for the rest of the question. If two lines are parallel, then they have the same gradient. Okay, because they're going in the same direction and have the same steepness. If the gradient of one line is m, then the perpendicular line, or all perpendicular lines, have a negative reciprocal value as their gradient. Okay, so you find the reciprocal and change the sign. So if you have a gradient of a line which is 3, then any perpendicular line will have a gradient of, well, the reciprocal means 1 over, so 1 over 3, and you change the sign. Okay, if the gradient of a different line was minus 3, then the perpendicular line gradients will be plus a third. Okay, and again, getting that right will give you in good stead for the rest of the question. You can also prove that two lines are perpendicular if you multiply the two gradients and they give you minus 1. Okay, so that's quite a useful technique to show that two lines are perpendicular. Right, so I've got some fairly straightforward stuff. Question 1. Find the gradient m of the line joining points A and B. So if I look at this, I need to find the gradient of the line. I think about my formula. Y, that m is equal to y2 minus y1 over x2 minus x1. Okay, and when I use this formula, in reality I can use any coordinate as long as it's on the line. So I could pick, for convenience sake, I'm going to pick A and B, but I could pick any coordinate in between. But I think I can read off A and B a lot easier than any other coordinate. Okay, so I'm going to pick A and B. I've got to make sure that I'm consistent with what I'm doing here. So the coordinate of A is 1, 1. And the coordinate of B is 5, 4. Okay, so y2 minus y1. y2 I'm just going to say is 4, the second y value that I see. y1 is the first y value that I see, over x2 minus x1. So it's going to be 3 over 4. Now I know my answer looks correct because it's a positive gradient, and a positive gradient means the line is going up. A negative gradient would mean the line is going down. Right. Now what I've got the gradient of the line joining points A and B, and in part B they're saying what would be the gradient of a line perpendicular to this AB. Well, if I'm using the hint in the corner here, find the reciprocal and change the sign. Reciprocal of 3 over 4 will be 4 over 3. I'm going to change the sign of it. That would be the gradient of a line perpendicular to AB. Okay, not too difficult there. Right, so question 2. Find the gradient of a line joining these 2 points and the gradient of a perpendicular line. So, change the move up a little bit. So again, this time I don't have a graph. I've just been given the coordinates as they are. And a really important sort of tip, which I always tell my students, label it. So the first coordinate that you see, label it x1, y1. And the second one, label it x2, y2. That means when you use your formula, you could just like look and label them correctly. So I'm going to find the gradient of this line. So y2 minus y1 over x2 minus x1. Okay, and I'm then going to substitute the coordinates as I've labelled them. So y2 is minus 8 minus, and be careful with negatives, students can also get this wrong as well. So minus 8 minus 1. Oh, have I done that correctly? I just said x1 there, so that's not correct. So it's got to be minus 8 minus y1, which is actually 2. Okay, and I've got to do x2 minus x1. So minus 3 minus 1. Okay, so I've got to do minus 8 minus 2, which is minus 10. Now I've got minus 3 minus 1, which is minus 3 plus 1, which is minus 2. Minus 10 divided by minus 2, the minuses cancel, and you're left with 5. So the gradient of this line between A and B is 5, and therefore the gradient of the perpendicular line M subscript P will be, well, 5 is 5 over 1, so the reciprocal will be 1 over 5, and you change the sign, minus a fifth. Okay, and that's it for finding gradients. I said I even made a slight mistake there, so it's easy to make mistakes when you're using the gradient formula and putting in the numbers. Okay, so I'm going to leave that there, and that's the end of the video. The practice questions are outlined here. Thank you very much.